Alright, my last video talked about what are slope fields. This one gets a little bit deeper into actually creating the slope field. So in order to sketch a slope field, you need to select any ordered pair. Typically they'll give you a bunch of dots, and so they'll specify what order pair they would like for you to start working with. You want to write it in a table with 3 columns named x, y, and dy dx. And then you're going to substitute the order pairs you choose into a derivative to compute the slope values at those particular points. So you're essentially finding what is your y prime at a specific x and y coordinate. Construct short line segments on the dots to approximate the slope values. Again, they're approximations. They are not meant to be perfection or an accurate representation. For a particular solution, sketch in the curve using the initial condition and guided by the tangent line. So all those little lines that we're doing, those are all of our different possible tangent lines at that particular point. Alright, number 1, consider a differential equation of dy dx is equal to x squared times the quantity y minus 1. So part A is sketch a slope field for the given differential equation at the 12 points indicated. So if you notice, I have all these little dots, and these are going to be my coordinates that I'm using. So for example, I could use this coordinate right here, which is -1, 0. And so I'm going to, on my table, I'm going to write in -1, 0. And the one above it would be -1, 1. And then -1, 2. -1, 3. And that gets me at the top of all my x is equal to -1. These are all coordinates, so we're writing down the points. And so now I'm going to come to where x is equal to 0. So my first point is x equals 0, y equals 0. That's the origin. Then x is equal to 0, y is equal to 1, x is equal to 0, y is equal to 2, x is equal to 0, y equals 3. And so those are all the points that are x is equal to 0, y is equal to either 1, 0, 1, 2, or 3. Finally, I'm going to where x is equal to 1. So if x is equal to 1, y is equal to 0, x is equal to 1, y equals 1, x is equal to 1, y is equal to 2, x is equal to 1, y is equal to 3. Again, these are all the list of all these points. Again, these little dots mean the different, what are all these coordinates. And so now let's go ahead and find our dy dx. Well, dy dx from the problem is equal to x squared times y minus 1. So dy dx is equal to 1 squared, which is 1, times y minus 1. So 0 minus 1 is -1. Well, that's equal to -1. So that's the slope at that particular point. Again, I'm going to square my 1 and then subtract 1 from my y coordinates. That gives me 0. So that means my slope at that particular point is 0. Again, square my x, that becomes 1, and then decrease my y value by 1. So my slope at -2 or -1, 2 is +1. And I'm just going to be filling out the rest of this. So how my slope is -1 squared is 1. Decrease the y coordinate 3 by 1, I get 2. So this is equal to 2. 0 squared is 0. 0 minus 1 is -1, so that's equal to 0. 0 times 1 minus 1 is 0, still is equal to 0. 0, 2 minus 1 is 1, which is also 0. 0 times 3 minus 1, which is 2, again 0. And then I'm coming to 1. So 1 squared is 1. 0 minus 1 is -1, so we have -1. 1 squared is 1. 1 y coordinate, decrease that by 1, I get 0. One squared is 1, decrease 2 by 1, I get 1. Decrease 3 by 1, I get 2, so my slope there is 2. So I'm going to be graphing all these slopes. So at x equals -1, y is equal to 0, I have a -1 slope. So that means my slope is just decreasing. At negative 1, 1, my slope is 0, so that means I have a horizontal tangent line. At negative 1, 2, my slope is increasing by 1, so tangent line is equal to, my slope for my tangent line is 1. At negative 1, 3, my slope is increasing by 2, so it's a little bit steeper. At the origin, I have a horizontal tangent line. At the y-intercept of 1, I have a horizontal tangent line. At the y-intercept of 2, I have a horizontal tangent line. At a y-intercept of 3, I have a horizontal tangent line. At my x-intercept, at 1, 0, I have a slope of negative 1. At 1, 1, I have a slope of 0. At 1, 2, I have a slope of 1. At 1, 3, I have a slope of 2. And so they want me to describe all the points in the xy plane for which the slopes are positive. And so if you notice, first of all, I need to somehow say all of these x-coordinates. So no matter what I have, when x is equal to 0, my slopes are always going to be 0. So x cannot be 0, because if it is, it's going to, if I multiply by any type of 0 right there, I'm going to have a 0 slope, so that's not positive. And if you notice, all my y values that create positives are when my y is greater than 1. So I need y to be bigger than 1. Okay. Part C, find the particular solution. If y is equal to f of x to the initial differential equation, with the initial condition f of 0 is equal to 3, draw in the solution. So I'm going to first draw in the solution, and then we'll go ahead and solve the differential equation. So I'm going to get rid of all these green lines so it doesn't distract you. So we're talking about the point 3, so let's go ahead and draw in our y-intercept. And then if I come over to the left, it looks like I have a decreasing slope. So I need to, because I have a decreasing slope, that means I probably need to go down and look at the lower left-hand corner, the next one down, and it shows me that's probably where I'm going to be connecting. If I move to the right, it shows me then I have a horizontal at my y-intercept of horizontal, so that means I can just slide over right next to the right, because it's just pointing me to go this way, and then it shows me I'm going to be going steeply up. And there we go. Alright, part C, find the particular solution of y is equal to f of x to the given differential equation with the initial condition f of 0 is equal to 3, draw in the solution. And so we drew in the solution earlier, so now let's go ahead and solve our differential equation. I copied down our formula for you, so dy dx is equal to x squared times y minus 1. So again, our first step is separating our variables. And so I'm going to divide by y, the quantity y minus 1, and I'm going to multiply by dx. So that gives me dy over y minus 1 is equal to x squared times dx. And so now I can go ahead and move up my y minus 1. And so since it's raised to a -1, that means ln. And this is going to tell me my coefficient, which is just going to be 1. So we're just going to use the ln of the absolute value of y minus 1 is equal to antiderivative of x squared is x to the third over 3 plus c. And so our second step, if you remember, is to integrate. Our third step is to solve for c. And so when x is equal to 0, y is equal to 3. So we're going to plug in. So y is equal to 3 minus 1, absolute value, equals x to the 0, or x 0 to the third divided by 3 is 0. So 0 plus c, which just gives you c. And c is going to be equal to ln of absolute value of 2, which is 2. And so now we can plug in. Our fourth step is to solve for y. And so my first step is I'm going to raise it, to get rid of the ln, I'm going to raise it to the e. And so now I'm going to simplify my exponent over here. So I have e to the ln of y minus 1 is equal to e to the x to the third over 3. Again, if I'm adding my exponent, that means I'm multiplying by like bases. So my base is e, so this times e to the ln of 2. Alright, now I'm in a position where I'm able to cancel. So these will cancel, and these will cancel. Since my initial condition creates a point where y is positive, f of 0 is equal to 3, I don't need to worry about my negative version. I'm not talking about a negative y-coordinate, I'm talking about a positive y-coordinate, so I'm going to go ahead and drop my absolute value because I'm talking about the positive version of it. Because the point that I chose, 0, 3, creates positive y values. This gives me times 2. So I have y minus 1 is equal to 2 times e to the x to the third over 3. And now I can add 1 to both sides. And that is my answer.